All right, let's kick it off. Austin, thank you so much for taking the time to be here.
Thanks for having me.
Tell us a little bit about yourself. Tell us what 00 is, what's the mission, and then we'll jump right in.
Sure. So 00 is not something that I've talked about publicly. We're not even technically launched yet. It's coming out in early December, but thought we'd do a nice little preview here. So at its core, 00 is a new, we're calling this thing an N1, so instead of an L1. It's a new infrastructure layer for distributed decentralized systems. In effect, we're trying to rebuild the internet from first principles, optimized for distributed systems and blockchain, but baking in a lot of components that are fundamentally missing today. And I think if you've been around the space for long enough, you've heard some vision or some version of this pitch from various types of companies. The difference is they've all been focused on software abstraction layers, things that run on top of the existing internet. We are building OSI level 1, 2, 3. This is a physical hardware infrastructure network, not a software layer running on top of the existing internet.
Great. So I think a good place to start is with IBRL. So for those of you who weren't in the room when Raj and Tushar were describing what this acronym is, IBRL is increase bandwidth, reduce latency. I think you're probably one of, in the handful of people in the world who's best positioned to describe what that means. Make those things a little more concrete for us. What are bandwidth? What are latency? Why are they important in the context of distributed systems? Solana specifically.
Sure. So if we take a step back and we think about what are key unlocks for innovation, I mean, going pretty much back as far as you can go back, it's some version of increasing the capacity to do work and reducing the amount of time it takes to do work, right? This is your story of the horse and buggy. This is the internet. This is everything that's kind of come since then. And so the idea of increased bandwidth, reduced latency is it's a North Star focus for high-performance distributed systems. It's been something Solana has been focused on since the FireDancer project was first announced. But really what we're focused on there is bandwidth is how much data space is available for certain types of activity. So in the context of blockchain, we often think of this as block space. How many transactions can you fit into a block? How fast is a block? And then latency is the time it takes to submit something and get an answer back. So if you play video games, or you have kids who play video games, they hear about ping time a lot. That is latency. That is the time it takes to get from your computer to the server. Now, this is like a classic problem in pretty much everywhere that time matters. The classic example of this is like Flash Boys, right? What they were trying to do with that is connect trading systems to stock exchanges with less latency than their nearest competitor, because if you can be first to trade, you can get first to profit. And that is not like a linear curve. That is a very exponential curve. The first person in makes $10 million. The second person makes 50 grand, right? And so when you're looking at this in the context of a distributed system, it's not the simple HFT problem of who has the fastest line between New York and Chicago, or who can get to the Nikkei index fast enough when a piece of information hits. It's how does N party get to N+1 party, right? How do you get from an arbitrary party located somewhere in the world to another arbitrary party located somewhere in the world? Because just because I have a super fast, super performant trading system located in New York, well, the next leader I'm trying to talk to in the blockchain, they might be located in Singapore. They might be in Mumbai. They might be in New Jersey, right? We actually, and you can know because the leader schedule is computed in advance, but that time it takes to get from where my system is to where it's trying to get to, it varies depending on where the block is being built. This is like a problem that pretty much every large company has also dealt with that has any sort of global scale. So Google started off with one server in one office in California. They now run numerous data centers just for Google search all over the world, and they have an average response time of 50 milliseconds. That is not enough time to get anywhere around the world. That gets you about a third of the way around the world, right? And so when we're talking about these sort of concepts, this goes back to the stuff Toli's been talking about for years about we want Solana to run as close to the speed of light as possible. And there's really only 3 ways to do this, right? You can make the speed of light faster, which no one's figured out yet.
It's on the roadmap, though.
It's on the roadmap. You can make the world smaller, also not really on the roadmap. If anything, we probably want to make the world a little bit bigger. Or you can do what we're doing with 00, right? Which is replacing these public internet pipes that everyone uses today that are very latency intensive. They have a lot of jitter, which is a measurement of the average variance it takes to get somewhere. And the paths are totally non-deterministic. So to give this kind of in concrete examples, if you're a validator in New York and you're trying to talk to a validator in Austin, Texas, that takes a certain amount of time, right? Just like we think about, it's weird to think about electrons and stuff moving through like glass at close to the speed of light as like slowly bouncing across the United States. But that's basically what happens. You have a very indirect path that you take from like New York to Austin, Texas. And you'll go through, you'll clear through Virginia, and then the packet will jump back up to Boston, and then it will jump over to Denver, and then it will jump back to Florida. And it does this because the entire routing system on the internet is built to reduce cost. It's not built for time-sensitive applications. So it takes, let's just say 45 milliseconds to get from New York to Austin on the public internet. In that same time, we can get from New York down to Brazil on the 00 network. And why is that? Because of a few different pieces. One is deterministic routing, so the fewest hop path needed to get there, and also dedicated bandwidth. So instead of this huge pipe of bandwidth that's shared between everyone else, you now have dedicated bandwidth lines just for these type of uses. And so 00 is created out of contributions from network operators all around the world, right? You may have an HFT firm, or you may have a data center provider that's running a bunch of validators, or you might have someone like Jito. And they're able to contribute portions of the network bandwidth to this. They install these switching appliances that act as nodes in this ecosystem, and it builds what is, from a network operator's perspective, a private, centrally managed high-performance network. But it's not actually that. It is a semi-private, semi-public, high-performance distributed management network. And this is like, no one has ever done this before, being able to take a bunch of different high-performance networks that are all run by different companies. There's no like one central DevOps team overseeing this, stitching them together, get them to talk their own common protocol, and actually run high-performance switching over that. Everything else that's ever been built is either the public IX system, Internet Exchange System, and like classic ISP routing, or it's fully custom private networks, the kind of stuff that the Jump Tradings and DRWs of the world have built out, or the stuff Microsoft and Netflix have built out for data model movement and all sorts of other CDN delivery networks and stuff like that. So that's kind of where the magic of this thing comes together. It's taking this technology that is like not groundbreaking, not super innovative, right? Like this has been like the staple of any private networking service for the last 20 years, and stitching it together with this decentralized technology to make it into something that is more than the sum of its parts. This is the thing that's like so counterintuitive. Like we use the term network effect businesses all the time. Private networking is entirely anti-network effect. If I run a line from New York to London because I want to trade on the London Stock Exchange because I'm a company based here, there's no benefit to anyone else. It's an entirely one-to-one business, right? But if you get like a 100 gigabit line, because that's the increment you have to buy in to get the most effective, latency effectively, maybe you don't need 100 gigabits. If you're trading, you really don't need 100 gigabits at all. You need latency. You don't need bandwidth. You're sending at most 50,000 orders per second. That's like a few hundred megabits at most of data. And in fact, data increases latency. So you actually want as little data as possible. So you have all this extra capacity, right? And so the whole idea of 00 is you can carve out a section of that bandwidth, and you can contribute it to this network. And you will earn tokens for that, right? But you will also then help build this global high-frequency transport network for blockchains. And so the idea is you get, well...
No, please continue.
So the idea here is you start to get validators co-locating on these networks. And they still have a public connection to the internet to fall back on if they need to. But what we're starting to see from this is you can build a system where suddenly the amount of time it takes to reach consensus gets much faster. Suddenly the time to finality gets much faster. You're able to, if anyone saw the demo at Breakpoint of Solana running 1 million transactions per second on a 12-node cluster on testnet, that was running the FireDancer client, which is this new thing that Jump Trading has been building. We've talked about this here at the conference before. That was running on the 00 network, though, and that's how they were able to hit 1 million transactions per second. If they were running over the public internet, they probably could have hit maybe 100,000 transactions per second. And it's nothing wrong with the public internet. It just was never built for performance. It was built for different characteristics.
Yeah, it's super counterintuitive because sort of bits you think of as a virtual resource, and you're sort of talking about the business of moving them from point A to point B in as much size and as much speed as possible. That's foundationally the problem you're solving. And yet, the units of that are physical resources. These are atoms that you're coordinating in some capacity, right? And that's sort of, so tell us more about the physicality of that, right? Like this fiber, the networks that you're aggregating are privately owned in some cases. So tell us about the market structure there in terms of why are they opting into the system? You know, what are the incentives for them? And what do you think about when you're coordinating these discrete assets? We talked about orchestration in the context of compute networks earlier. In the context of bandwidth, I imagine the variables are a little bit different.
The variables are a little different, but I think one thing to sort of remember is almost every internet entrepreneur starts out with a dream of building global distributed systems that, you know, whether it's Facebook, which is a distributed system in its own right, in a different way, or whether it's Google, they all start with these very abstract, lofty goals, right? How do we think about things in the abstract? How do we move data around the world instantly? And then you get to a certain size, and like, I don't know how many people know this, Facebook is one of the largest data center builders in the world. They also own a ton of undersea fiber cables. They literally wired up the Philippines with internet, running fiber between all the different islands so they could sell people ads and onboard new users. Like, you run really quickly when you're building a global scale business into your barrier to growth and your barrier to adoption is not the product, it's not the software, it's not how good you've like created a pitch. It's that you need to be physically where users are with your servers and with your connectivity, or else you're not going to be able to provide them the type of performance and experiences that you need. And so I think blockchain is going through this revolution. And, you know, to Anatoly and Raj's credit, like, Solana was the first network to realize this. It was the first blockchain that was built with performance in mind from the get-go. This is proof of history. This is the idea that, you know, Turbine spits data out in multiple locations and propagates state around the world as quickly as possible. It's the idea that you have erasure coding built into the way blocks are propagated so they can be backfilled. It's a lot of the stuff that, like, in an academic sense, you never think you need because you're always building. It's like the whole physics joke about, like, you know, a physicist looks at a cow and they see something roughly spherical. Right? It's like you always like reduce to the model that you know how to deal with. And when you're coming out of very academic institutions, nothing against Stanford, but like it's all very academic in the structure. When you get into the practicality of how this works, like the Solana founding team came from Qualcomm, right? Where like the theoretical performance of your Wi-Fi in your home on the box, it says 2.4 gigabits per second, and like good luck, right? Like if you run a speed test, you're never getting anything like that because real world is so different than theoretical. And so as blockchain has proliferated and as these technologies have scaled to the point where I think on Solana, at least, we have demand for at least 200,000 transactions per second today, and that's just with the applications today. As we start to look at these global scale numbers where you're going to say, oh, we need X number of transactions per person, you get to estimates that are looking at tens of millions of transactions per second are needed to actually support the needs of users. It doesn't matter if you're putting that over L1s or L2s or L47s on Ethereum, like you need throughput, right? And that means you need physicality. And the minute you're dealing with physicality, you're dealing with censorship choke points. Right? And this is the problem with all of these things is that like the idea of bunker-proof, nuclear war-resistant Bitcoin is great until you realize the nodes still have to communicate with one another, right? And whoever owns the links, right? This is the whole thing about like what do the dictators do first? They take over the communication channels. This is exactly all these things we're thinking about when we're thinking about how to build a network like 00. So you asked about sort of how do we incentivize creation, all these sorts of things. It's a token incentivized network, right? So you get rewarded for providing bandwidth and connectivity and tokens, validators and other RPC services, MEV clients, anything that is really time sensitive and where time matters, they pay fees to use the network. There's prioritization fees. All these sorts of different economic models that are very native to crypto come into play here. But at its core, what this is about is it's not about increasing the performance of a single validator. It's about increasing the aggregate performance of the entire validator network and doing it in a way that goes back to something that I think is like sorely missing in crypto. Like you go back to the early days of crypto and everything was focused on how do you create cooperation out of like pure capitalist, selfish economic incentives. I have every incentive to cheat you. But if I cheat you, it hurts me more than not cheating you. That is the basis of proof of work. That is the basis of proof of stake. And too many things now are based on this sort of donation of public good resources and the goodwill of a foundation and all this type of stuff. And we try and stay away from that on Solana as much as possible. But we're trying to build a network that works on the same principles here. And I think that is like the major unlock for getting these networks up to being able to handle millions, if not tens of millions of transactions per second.
So maybe it's worth given the fact that the Solana validator that produced those sets of transactions in that demo at Breakpoint for FireDancer was using the network in some capacity. Is it worth double-clicking a little bit for whatever you want to share around what was mechanically happening with the network there, right?
Yeah.
Specifics of the protocol. I know there's a lot of work around, transaction filtering, building things at that layer that are worth going into. So.
Yeah. So the transport layer is one of the main components that you have to start with, right? How do you build? Excuse me. How do you get the fiber connections necessary to connect into all these different places that nodes are run? And we are really literally talking about physical fiber networks. Like this is not one of the it's very easy to think of a network as an abstract concept. Like you fire up BitTorrent and you pirate a movie and it's a network, but it's not a physical network. It's a software overlay network. If you're connected to WhatsApp or Signal, they're all software overlay networks. This is much more like the fiber or the coax cable coming into your house that you get internet from. So we're talking about a physically interconnected network here. The place this goes pretty quickly is transport is valuable, but there's a lot more we can do in resource sharing. This network is based on the principle of resource sharing. And if you kind of go back to Elinor Ostrom's work in the late 90s, early 2000s around common pool collective resource management in absence of authoritarian systems, all of her work really dives into how do you set up systems where people collectively manage common resources, and it's all about checks and balances. And I wish, it's too bad she died in the early 2000s, but if she'd lived long enough to see blockchain, I'd be very curious to see what she would have written about it. But I think she won the Nobel Prize in 2010 or something. But anyway, the kind of work we're structuring here is really around those type of incentive structures. And so you build out a physical network, you add in filtration, right? And filtration is all about doing two things. Right now, every single validator on every blockchain is exposed to the full force of the open internet. Mm-hmm. And so if you've seen these things before where, Solana validators have gotten DDoSed, right? This happened a lot back in 2022. You'd have 80 gigabits of traffic of inbound transaction requests. Not necessarily malicious, just people who really want to mint this NFT or they really want to do this arbitrage hitting the network, and it blocks out other legitimate traffic. This has been in part addressed through things like Quick, which is networking technology, and priority fees, where there's now an incentive to pay more as opposed to incentive to spam. But it's still something about 70% of a validator's time is spent on deduplication of traffic and signature verification of traffic. So what that basically means is 70% of the time, the validator is not building a block. It's just getting ready to build the block. And they only have 400 milliseconds, right? And so we can actually implement all of that signature verification, all of that deduplication using FPGAs. And FPGAs end up being the field programmable gate arrays. These are basically, to overgeneralize an FPGA, it's a CPU you can reprogram. So the transistors and the logic gates are not fixed like they are on your typical Intel or Apple CPU. They're fluid. They can't run it anywhere near as fast speeds as a normal modern CPU, but you can reprogram them on the fly, and implementing code in hardware is always faster than implementing it in software, right? This is why Bitcoin runs on ASICs and why AMD GPUs are so good for AI workloads and graphics, or NVIDIA are so good for that, is that they're very good at a very narrow band of things, but if you try and do anything general on them, they get incredibly slow. So FPGAs you can reprogram as you go. And so one of the things we've been able to reprogram these FPGAs to do is signature verification and deduplication of packets. And so there's this flood of inbound traffic that hits a Solana validator right now. By using the 00 network, that traffic ends up being handled by the switch. The switch can throw out all of the junk. It can only pass through things that are properly verified. You can even, program these things to create different flags for these are high CU to fee ratio transactions. You can do all this sort of sorting and inbound work in the switch. And the best part is one switch can support dozens and dozens of validators behind it. This isn't a situation where it's like one switch to one validator. We're basically filtering at line rate here, about 100 gigabits per second of data that can be handled through these appliances. And you can always add more of them. And so this is kind of, I know this is like, we've gotten pretty decently deep technically, so I apologize, but like one of the real components of this is that blockchain is about to get a little bit more complicated on the networking stack, but it's actually going to be simpler in terms of like from a validator's perspective. If they're locating on this, they no longer need to go out and get Cloudflare and manage all this DDoS protection around them. They can simply operate on the 00 network, and they can actually own and deploy that switch, and they can bring bandwidth into whatever data center they're currently operating in. They don't have to move everything to where a 00 node happens to be. They can permissionlessly extend this network. And so blockchain is sort of only the first use case and avenue for this. You were talking about AI earlier, and one of the major issues we've been talking with a bunch of different training groups on is this start-stop model that you're describing, where they have some reserved capacity and some non-reserved capacity. Well, that changes, right? So maybe at one point they have 100% of their capacity used from a big contract job, and then it drops to 70%. They can't just restart instantly. There's a whole state sync they have to do to pull other changes that have happened from models elsewhere in the world. And so things like 00 network can interconnect a lot of these independent data centers. There's actually a lot more independent data centers than there are aligned data centers, but they're not connected to each other. And so all of that sort of, how do we use 20 data centers as one data center? Like logically, it's not that hard of a problem. Practically, no one has the economic incentive to do the collection. Are you going to charge the client $500,000 to connect them all just to run a $20,000 job? Is the data center going to do it? No, because they're probably owned by a PE firm, or they've got a small business loan to build the thing out. They don't have that spare capital. The ISPs have no incentive to do it either, because once you build that connectivity, you stop transiting over the public internet where they're currently getting paid. And so there's this whole gap right now on connectivity fabric, and a lot of people have tried to go over it, and we're trying to go under it instead.
Yeah, it's been really interesting to see sort of the distributed engineering brain trust around Solana over the last few years run up against a threshold in compute and bandwidth or any other technical parameter, and then just blow past it and like build dedicated infrastructure in order to solve that specific problem. And I imagine we'll see that pattern continuing over the next few decades. But the more important thing is that it's possible to reutilize that for other use cases, right? And so, you mentioned AI a little bit. What else can we expect to see 00 get used for? What are some of the more quote unquote Web 2 use cases that could be compelling?
Yeah, so I've spent the last 4 years at Solana Labs and then Solana Foundation, and one of my core theses of that time was that we are not smarter than the developers building on the network. And so one of the ways that that manifests itself is you always build the systems as generalizable and as low level as possible, right? There's a lot of folks out there that say we have to build complete full stack product experiences and take big bets. And that is certainly an important component, but you have to build that all in ways that people can take one component and run with it. A great example of this is like Metaplex, right? Metaplex is like the canonical NFT standard on Solana. The entire thesis of Metaplex was totally wrong. right? The first version of Metaplex was users want auctions, artists want auctions, they want custom storefronts, they don't want fixed price, they don't want all this stuff, right? They want to get away from OpenSea. And turns out users want fixed price, they want Magic Eden and Tensor, they want all this other stuff. So all of Metaplex was wrong, except the core idea that people wanted NFTs on Solana. And by separating that out as one different module from the rest of the system, that idea was able to take off, and Metaplex is the success that it is today. So this is a long way of saying, when we're building infrastructure and frameworks for 0.0, we're not necessarily saying, oh, this is how you build a CDN service or an AI workload management service or a X or Y or Z. Like, I think a failure case for a lot of blockchain infrastructure products is you go to their website and it looks like IBM. You're like, oh, here's the drop-down for choose my adventure flowchart use case. And like, that is not how you build a product. If you're building an L1 blockchain or a low-level blockchain like 0.0 system correctly, you're building it in ways that people can build totally different business models you never even imagined on top of it. No one at Solana Foundation was like, you know what we really need? Pump.fun. Like, that was a completely organic, like, thing that emerged from the community and completely changed the topology of what was going on Solana. No one thought, you know, we need a proof of work token operating on a proof of stake network. But Or launched and was able to do that and created all sorts of problems. But like, these things are so much better when you have like the full force of innovation behind it and you get rid of this sort of like centrally planned economy system, which is I think a lot of what's been happening on Ethereum the last 4 years and has been kind of sad to see.
So it's going to be generative. There's going to be a lot of new stuff that we can't frankly name.
Yeah, I mean, I can list out a whole sort of thing, right? You can have distributed gaming systems that want to break away from the monopoly that Azure currently has, not on the gaming side, but on the hosting side. The Azure monopoly is so strong that PlayStation uses Azure to host all their multiplayer gaming systems, right? If you're an indie game developer and you want to build an alternative to that, you can build it on 0.0 network. If you are Pipe and you're building a decentralized CDN system so video and content creators don't have to go through YouTube anymore, you can build that on top of 0.0. You know, if you're Jito and you want to deliver bundles as fast as possible to the nearest validator anywhere in the world, you can do that. If you're an Oracle and you want to be able to have high-frequency data move around, you can build that. And you're not using the 0.0 Oracle API software SDK kit that we're developing. You're rolling up your sleeves and you're building that yourself, and you're turning it into a super profitable business, and you're building your own type of services on top of 0.0. It's like every cable company in the world has decided they want to be a content company for some reason, and then you have Verizon buying, what did they buy? Yahoo,
yeah.
And like writing it off for $11 billion, and AT&T ruining HBO, and like, we don't need to do these types of things. We just need to get the base layer right. It's the same thesis as Solana. Increase bandwidth, reduce latency, better entrepreneurs will come along and build things you never even imagined.
Yeah, I mean, so I think maybe to double click a little bit more on the token aspect of this, right? You think about the supply side of this network and the kind of stakeholders we're talking about. That's always been my fear and my general concern is like the second you're talking about someone who's not a 24-year-old who's interested in tokens, it's like maybe it's a little bit harder of a sell. I have seen firsthand that that is no longer the case. And with each passing year, institutions, quote unquote, become more well equipped to hold crypto assets. But in general, how do you think about the idea of giving these sets of entities tokens and making that sell to them, and how does that entire flow work on the supply side?
Yeah, so the blessing and the curse is a lot of carriers nowadays are owned by private equity firms, right? The curse is a lot of private equity firms have like cash targets and margins that they're operating towards, and those guys are like hard to talk to, right? The good news is that there's a lot of people who buy capacity from them, right? The thing about like telecom is it's old. Like, it's a 100-year-old industry, and so it has the same 7 layers of middlemen that Visa does, right? And like, you swipe a credit card, there's 7 entities in between you and the merchant, right? And telecom is kind of similar to that. So in some ways, our goal is like, if we can get like NTT and Verizon and like Charter, and like if we can get the actual tier 1 ISPs interested in this, That's like the ultimate goal. But we don't necessarily need them. The high-frequency trading links are not built on top of those networks necessarily. They're built with direct relationships with the actual cables. Because all cables are not created equally for undersea cables, right? There's different purities of glass and different amounts of wavelengths you can pump through different channels and all these sorts of things. And so one of the beauties of 00 is like if you're going out and building a high-frequency trading network, you need all of the same thing, right? You need full wave service with the same optical transducers, you need the same switching hardware, you need everything to be standardized. We are not competing with HFT firms, right? We can take the stuff that was state-of-the-art 10 years ago in high-frequency trading, and we can use that in 00 and provide probably 100x improvement over the public internet infrastructure. And so we can mesh a lot of this different stuff together. And so if someone wants to contribute packet service in an L3 VLAN, that's fine. If they want to contribute a full wavelength down on like the OSI L2 stack, that's great too. And that's kind of one of the real advantages here. Getting people to understand tokens is always hard, right? But I think, as you said, the world's changing in that direction where it's a little bit more intelligible. And the other thing too is, part of the reason that you raise capital as a foundation is that you can provide temporary US dollar backstops on these things until people start to understand the true promise and potential of blockchain.
All right, Austin, one last question. I know we're already over time. You're going to make the internet faster. What does the world look like in 5 years? So I ask this because there's this vision of turning these things into commodities one day. Is bandwidth a commodity? Is there a world where it gets priced in that way on chain? If not, what is the ultimate vision?
10 years?
10 years?
10, is that what you were saying?
5 years, 10 years,
okay.
whatever it is.
So let me say, in January 2027, if Solana's not running near 1 million TPS on mainnet, we've missed our mark on 00. And if there isn't at least 2 other networks that are trying to rival it in terms of performance, we've also missed our mark, right? I'm a bit of a Solana bull. But I'm also, I think more fast blockchain is better for the world, and we need to have, the more competition Solana faces, the better Solana will get, right? We need networks that are able to support all this type of thing. 5 years out, maybe we have public key-based routing. We've replaced IP address-based routing with pub key, private key, handshake encryption, and protocol routing based on that. That's one of the things that we're working on building is sort of a new TCP/IP stack that runs on pub key instead. You fast forward 10 years out, my hope is that every business anywhere in the world can have a system where they can natively specify a priority fee on packets. That's fundamentally what we're trying to build, right? You switch everything over to encrypted public key, private key encryption for protocol routing, for everything routing. And then if you are trying to build a game and you need low latency, high bandwidth connectivity between the endpoint client sitting in anywhere in the world and the game server, they're able to pay for protocol prioritization without going through a ton of other software systems.
It's a hell of a vision. We'll end it at that. Thank you so much, Austin.
Thank you.